product, and it was like a square with, and then it had an OH. Do you remember that one?
Yeah, I have it written down somewhere. Let me find it super quick.
Then I think the reactants were HCl.
Okay, yeah, I have it.
Right?
Yeah.
Okay. So this one, obviously, like, it gets protonated, right? That leaves. And then you have a carbocation, which is, right? So then, obviously, this is like the one, like, remember the SI leader said that they love to do acyl shifts, acyl shifts?
Yeah.
So I figured this was going to be that.
Yeah.
So then I think I broke like this bond, so to speak. So I connected it here. So that is like a 5-membered ring.
Mm-hmm.
And then I guess it doesn't matter like which one is which.
Mm-hmm.
As long as one has an ethyl group and one has a methyl group, and they're like one away.
Yeah.
And then the one that got the positive charge was this tip right here, because obviously like this bond broke.
Yeah.
So the positive charge was on the ethyl group.
Mm-hmm.
And then the Cl went there. So like,
yeah.
Then the pause went away. So we can agree that that was the answer, right?
Yeah.
That's what I got to. I don't know, for some reason I was thinking that maybe it wasn't, but I was like, okay, cool. So that one, like, for sure, we agree that was the answer. I'll put a check mark. The second one was to assign RS, and I think
That's my thing though. Like we got because I think you said you got 6 points back too, so we got like still C's on it.
Yeah, I don't know. That's what I'm saying. Like, if I can see, because okay, like the nucleophile one. Okay, I even said I missed that one because I was like, I don't know. Like, I mean, I know how to tell between a weak nucleophile and a strong one. Like, if one's like an OH and an ONA, but they all had Na, like they were all ionic bonds. So at that point, I was like, I don't fucking know. I don't even remember. I didn't want to remember how to distinct from those. So I knew I got that one wrong. Then there was one of the synthesis ones I was going to go through. Like, I thought it was a T-butoxide, but it wasn't. It was like an ethyl. And like, I think, and since he does molecular formula, like for some reason I thought I saw a subscript, so that's why I thought it was like the bulky one. So I was like, okay, I know I missed that one because I thought I created a subscript where there wasn't.
Mm-hmm.
So I was like, okay, whatever, that's 2. And then some of the synthesis ones that he was like, oh, well, you should know it's the major product. Okay, that was like 2 more questions, but that's still like 4.
Yeah, it doesn't warrant a C.
I missed 8.
Yeah.
So I'm just like, okay, so I'm gonna see if I can find the other 4 that I missed. Because if I don't find them, I'm gonna go to his office and be like, where did I mess up? Because I don't see it.
Was that a dash?
Yeah, I was like gonna change it right now.
Sorry.
This is a methyl group. So, and this was H. So this one, this one was 4, obviously.
Mm-hmm.
This one 3.
Mm-hmm.
This one, I think the polarization was OHH, and this one was N and N.
Mm-hmm.
So that makes this 1, 2. So
Mm-hmm.
it's like this, which is S,
Mm-hmm.
but that's not in the back, so it's R.
That's what I got.
Yeah, I got R too. Cool. So cool. That one was right.
I should get a highlighter and mark the ones that are right so I remember.
Yeah. The ones that we have determined are right. Like, he gives a shit. Like, we only know that this is right. So we want our point.
No, literally.
Okay. The next one is what reaction sequence would accomplish this synthesis. So I think this is the one that he's like, I chose ones that would get you this. Actually, hold on. That's a 3. And then you're supposed to have that. Right. So
let me find this. But you can keep going. Okay, I found it.
So this one, okay, so like one of the options was, I think I wrote down all the reagents for this one. Was SOBr2 and
What was the question format? Was it pick the reagents?
It says which reaction sequence would accomplish this?
Oh.
The synthesis or something like that.
Yeah.
It says what reaction would accomplish this? Pyridine, and then so that's one, and then it was ethyloxide, ethanol. I was like, how do you say that? Ethanol. And then it was PCl3 and what is this?
I don't remember which answer.
Ethoxide and ethanol. That's a solvent. Then it was HCl and the same as this, and A, and ethanol. And then, I'm still on page, yeah. And then HBr and ethanol. Okay. So how I did this one was I was like, all right, so we have to have something that has like a methyl shift, because that's how you got this one. Yeah. And it has to be a methyl shift and a substitution reaction. Right? Is that what I got? Yeah.
Substitution. I actually don't remember what I put because my work was literally a messy piece of shit.
Yeah, because it's substitution. So I was like, it has to be like SN1. It has to be SN1 because SN2 would give me an ethyl group right here where the OH is. So it can't be SN2. And an elimination reaction will obviously give me like a double bond somewhere. And obviously I don't have a double bond. So one of these has to be an SN1. So this one obviously converts the OH into a good leaving group with the Br. The ethanol is a weak base, weak nucleophile. So it's going to be E1 or SN1. And a secondary, which is what this is, wait, hold on, secondary, if that one leaves secondary, yeah, with this, it's going to be a positive charge there. Hold on. 1, 2, 3. So you'll have a positive charge. So if it's SN1, you're going to have the shift or whatever. So this one, oh yeah, and since there's no heat, this one has to be SN1. So I was like, okay, this could work, right? Could work. This one, you're going to have a good, mix this into a good leaving group again. You'll have a Cl instead. But this is a strong base, strong nucleophile, right? And what is this? Protic solvent. At secondary position, the major product would be an E2, product. So that one can't work. The HCl makes that into a good leaving group. But then again, you have a strong base, strong nucleophile, and a protic solvant. So that's going to be an E2 reaction. So that's not going to work. And then HBr makes that into a good leaving group. That shit leaves. You get a secondary and a weak base, weak nucleophile. There's no heat, so this one would be SN1. So this one could work. So for this one, I chose more than one. More than one answer. So obviously you don't know what to put, but did those reactions? Yeah, right.
I know SOBr, the first mechanism works. I know the second and the third do not. And then I just want to verify the last one super quick because I wanted to make sure. So deprotonated would create a carbocation. Yeah, that would be an SN1 reaction.
Yeah, for this one too, and the other thing that I got stuck on, I was like, oh, maybe that won't work because HBr does have a carbocation rearrangement. But even if you have a carbocation rearrangement, like before the SN2 reaction, oh wait, hold on. If you have this at a tertiary, yeah, that would still be E2. Because HCl would make this, right, this third one, but at a tertiary, which is it now, you would still have E2 as your primary mechanism. So that one still doesn't work. So then with HBr, you have your carbocation arrangement, and it becomes a tertiary, and it would still be SN1 because this is a weak base, weak nucleophile.
Yeah, I do remember putting more than one.
Yeah, so
I just wanted to make sure.
More than one. This one I have to ask. So
if it's not the right answer, I would literally be shocked.
I'm gonna put like a question mark there. More than one. Because maybe that one was one of the ones. I feel like the other ones that are gonna be wrong or we got wrong might be a synthesis ones. Because I feel like the straight up question ones were like too hard to miss. I mean, too easy to get wrong. Okay, so the next one is like which has an enantiomer. I don't remember all of them, but I know I chose this one. Because the other ones I had a plane of symmetry and this one doesn't. There was one that I think maybe people may have chosen that wouldn't be right, but was this one? Because it still has a plane of symmetry. Does that make sense?
I'm just trying to find this one.
Like, those two were the only ones that were kind of close, and then everybody else plane of symmetry.
I don't know. What was what was the question?
It was which one has an enantiomer?
Oh, I remember this problem. Yeah, I didn't even write it down because I thought it was easy.
Yeah. So this is the one I chose.
Yeah, that's the one I chose too. Exactly. Because I remember in the book, I don't think we talked about it in class, which I thought was low-key like messed up for the other students. But we didn't talk about how on the right, like the molecule on the right, it does have an axis of symmetry. Like I don't remember him teaching that in class.
No, he didn't.
But I knew it from the
I remember it was in the book though, because they talked about like, chop something in half. Like when they were describing, I don't think they were describing that. They were describing like tetrasubstituted, like if it's in a pi bond, like how to tell if something has optical reactivity. And it was saying how like even if these two groups are different, like you can chop it up in half. I don't know, something like that. But I remember that's how I was like, well, if you cut that in half, it would still be symmetrical. But this one you can't cut in half because it wouldn't have.
Yeah, I have it written down. It was like an inversion thing. Like it was, even though it's in a different. Oh my gosh, I feel like other people would be confused about why we chose that one. I'm gonna try and find it in my notes really quick.
And then the next question I have was like, which arrow formalism is correct for dehydration? I don't remember. I think it was like a ring, maybe.
Oh yeah. If whoever's like watching this, sorry to interrupt you. Whoever who's watching this later, and doesn't understand why that compound was chiral. In the book in chapter 5, it talks about inversion, and it's a type of plane of it's a type of axis of symmetry. So it would be a meso compound. Sorry, I just wanted to make sure that was included.
Yeah.
Okay, I'll let you keep going.
The next one was like it was describing like the dehydration mechanism, and it was showing the arrows, like all the arrows are correct. I don't remember, but I remember writing down. I
remember what you're talking about. Yeah.
Yeah, I remember it was proton transfer. Like I mentally was like, okay, if you have a proton transfer, good. Then you have loss of leaving group. Then you have another proton transfer.
Did you say there was no? Did you say there was like no? There was no flaw. Like it was.
Yeah, and then there was another proton transfer, and I think it was with H2SO4. But like this one had like an H over here, and then it went like this, I think. And then this one had like the OH2 like leaving.
Yeah.
So it had like from the bond. And then this one had like the methyl group go over there. Or no, a hydride shift. So then it was like this. And then the proton transfer, it grabbed one of these hydrogens. Like I think the OHSO4, whatever the freak is negative on there, right there, I think. And then this one like grabbed one of these and then it went there. But I didn't see anything wrong with that.
Yeah, me neither. There was no error.
Yeah, I was like, yeah, the H2SO4 go gets it. Yeah, so I feel like that one was right.
I'm confused about what we got wrong.
Yeah, I mean, we're gonna come to it. Oh, the next one is predict the sign of delta S. So it was like a linear compound, and then it went to like a cyclic one.
Yeah, I said entropy decreased.
Yeah, I got negative.
Cool.
And so, like, for those people who are like, what do you mean positive or negative? The delta S is negative because you're going from you're reducing the disorder. So, like, if you have like a linear compound, you can like twist and turn it and adopt different conformations. But in a cyclic compound, you can't twist and turn it. So it has less conformations and so it's less disorder. Like the disorder goes down. Like its ability to change goes down. So that's why it's negative.
Yeah.
If you were to go this way, it would be positive. That was in the book. I think an example like this was in the book, where you're going from cyclic to linear.
Mm-hmm.
So if you saw that, then you would just know that the opposite is the opposite. So yeah, that one was that one. Then the other one, I think this one, I don't think I got it wrong. I don't think I chose the wrong answer unless they're being really fucking assholes about because this one was a transition state one. So
I remember which one I picked.
This one you had to do the transitional state for iodo ethyl. I don't know how you say that. And methoxide, which was MEO. So this one actually was from the book, and that's how I remember it. And I remember the book had like the H's on wedges, because you have a forward and backwards attack, so it wouldn't be, and they happen on the same plane. So you have your leaving group, and then you have your arriving group. Mm-hmm. And then I remember this one was partially negative. And then obviously you have your little thing. In the test, this one I think was negative. And I couldn't remember in the book, like, are both of these partial? I know this one's partial. I'm like, but is this partial or is this negative? I'm like, I don't know. And I think this was like, one of the options was like none of these.
Did you put none of these?
No, I didn't put none. I chose this one. One of them had like, and then there was another one where it was like the plane was different, but I don't think that should matter. Like it had the I over here. I'm like, I don't think it matters, like, because that's how the book draws it. So this is what I'm saying, like, I didn't even go back to check in the book. I don't know if you have the book there. Can you pull up this picture? It's where was transition states at? I think it had to be chapter 7. And
I have it in my notes. Where did I just put them?
Okay. Because, and that's what I was saying, like, if he's gonna be super anal, like, no, this isn't supposed to be partial. Like, I should have looked it up in the book. But if the book is not like that, then
I must have been fooled because I thought it did say partial.
Yeah, the answer from the test was this. This is what I chose. One, I had the negative on the O and the partial on the I. But this one's saying, like, I don't know if this is partial. Maybe like, oh well, this is supposed to be partial and that's why it's wrong. But then I feel like that's such a shitty ass move, like, why are you gonna be so particular? Because all the other options, one of these was positive, one of these are, so I knew that wasn't the case. One of them, they're both negative, and all the other 3 options had either flip-flop, they're both positive, or this one's positive, this was a negative, or whatever. This was the only one that had both negative charges, only this one was a partial positive, and this was partial negative, and this was full negative. And I'm like, he's gonna be a dick and be like, oh, well, that one didn't have the partial, so that one was technically wrong. I was like, you motherfucker, you obviously know that I know the essence of this, what's going on, and I feel like that should triumph. You know, like I didn't remember from the book that one was partial.
Oh my god.
I hope it's
Too many
you
notes.
find it. No.
No, I didn't find it. I'm sure it's
See, so this one is one that's like maybe if he's being a dick, and if he does say, yeah, that was wrong because this one's supposed to be partial too, not just negative. I'm like, you're an asshole. Like that was low key tricky. That was like you were trying to get us, and you got me. You got me. I'll say it. You got me.
I didn't even notice that I didn't have a partial sign. I thought it did.
Yeah, no, I did notice that because I was like looking at the other signs. Okay, that one's positive. I'm like, wait, this one doesn't have it. And there is a none, but I'm like, I just was battling, like, is he gonna really be that big of a dick? Like, is he really that dick, like a dick move? Like, or, you know, or what? I'm like,
we put this on YouTube and he finds it.
yeah, you're a dick for that. So, yeah, I think this one might be a maybe. Like, this could be one of the 8. But who knows? Maybe if it is one of those ones I got wrong, I'd be like, dick move, bro. Like, that was low. Like,
you're gonna present these to him, right?
Yeah, like I think if I can come up with the ones I think I missed, I'm gonna go talk to him and be like, are these the other 4 that I missed? Because I said like I already know like 4 that I probably did according to his arrangement. But I'm gonna be like, that's messed up. Because I remember even him and Han saying like, oh, we're not trying to trick you. I'm like, this is trick. This is just totally tricky. You were trying to trick us. You know, whatever. That was that one. The other one is which reaction sequence accomplishes this synthesis? And again, it didn't say major or minor, just what accomplishes this synthesis. So, and I think it was CN, and this was, this is a wedge, this is a wedge, and this is OH. And the options that I chose was SOBR2 and pyridine and NaCN. And this was like one option. And then a second option was the tosylate and pyridine and NABR and NaCN.
I hate myself for not writing these down.
So I don't remember. Let me see if I wrote somewhere some chicken scratch shit.
I know. I should have been more organized. I guess I didn't think I'd have to reanalyze the freaking exam like this.
Yeah. What happened? Why? I don't get what you're trying to tell me. Can you hear him? Sorry. My nephew was like, went to Panera Bread. Sorry guys for who's recording, but this is like a funny story. We went to Panera Bread and like he's over here complaining. He's like, we're never going there again. I'm like, why? He's like, because my stomach hurts. So he apparently got diarrhea and he wants to blame it on me. You got diarrhea because you don't drink water.
Technically that would cause constipation.
I don't have diarrhea and I have the same thing. Sorry, everybody who's watching this later. Okay. Liam, shush! I'm trying to do something. Okay.
Oh my god.
All right. So
it would not be option 1, right?
So
it would be. It would be. Never mind.
Yeah. So this one makes it into a good leaving group with inversion.
Yeah.
So it'll make it into a dash.
Mm-hmm.
And this one is a strong nucleophile weak base at a secondary, which would be SN2, and that would make it back into a wedge.
Wait, so what were the 3rd and 4th options?
I'm trying to see if I can figure out my chicken scratch. Okay, I think it was HBr and NaCN. And another tosylate.
Wait, so the second option would not do it, right?
This one, the answers were like A or B or C and D. Like it was A, B, C. I don't know if you remember. Like it was either A is right, or B is right, or A and B are right, or C is right, or C and D are right.
Yeah.
So
there was like an E option, and like where there was an E option and like the answer choices didn't even include E. Did you notice that one?
Yes, there was one where it was like a blank, like it had E, but there was no E in the thing.
Yeah.
I chose the one that was like A and B. I think this was A and B. I chose the one that was like A and B are eligible. And I think the last option was a toss-a-wood again with NaCN.
Okay, I'm pissed right now because in the second option, I thought it would not work because of this reason. So I thought after we treat it with the TSCL and pyridine, it would create an inversion, right?
Toss-a-wood does not have an inversion.
Oh, shit.
Yeah, toss-a-wood doesn't invert.
I already like forgot the material. I like blocked it on my brain.
Yeah.
So it would not have inversion yet. Okay, and then the BR would attack with an SN2 reaction. But
yeah, this is strong base. Yeah, strong base, weak. No, strong nucleophile, weak base. SN2.
What was it though? Like he told me that which one is a stronger nucleophile, BR or CL? Not a stronger, yeah.
I feel like CN is a stronger nucleophile because it's triple bond.
No, like between BR and CL, because he told me that BR will not always act as an SN2 reaction depending on, he literally told me in office hours, he said, I'm not going to trick you and make you decide whether like CL or BR or I is a better like leaving group.
Oh, like if this was NaCl? Like if this
so like, sorry, I wish I could show you. So
with the tosslet, because it changes it to Cl, right?
Yeah. So if it's I'm forgetting words. If it's an alkane with a Cl attached to it, and then we have a Br minus in solution. He said, I can't remember which one is a stronger nucleophile. Is it Br or Cl? I think it
goes like this. Iodine, Br, Cl.
So Br is a stronger nucleophile than Cl. So it would attack as an SN2 reaction here.
Just to confirm.
Well, I looked at the periodic table and I think that's correct.
Yes, Br is better than Cl.
So then it would be an SN2 reaction. So I agree it would be A.
I didn't even think about that. I honestly, that was not even wasn't paying attention to that at all.
Because he told me in office hours he wasn't going to test us on that.
Well, that was a dick move. He did. Because this is Cl and that one's leaving. Because Br is a stronger nucleophile. So it would, yeah. So then that turns it into a dash. And then the NaCN turns that into a wedge.
Yeah, I did put A and B here, like you.
Yeah, and then these ones, this one, the HBr, makes that to go, you have Br. This one, I couldn't remember if HBr and HCl, like that type of H whatever, it has an inversion or not.
Wait, let me see. Because if it was an SN, I remember that. If it's an SN1 reaction, so let me write it out super quick. So the oxygen deprotonates the H from HBr. It becomes a good leaving group, and we're left with a carbocation. And then the Br would attack in an SN, again, an SN1 mechanism. So there's no change in configuration in an SN1 reaction. So it would still be on a wedge.
And that would make this a dash, so that wouldn't work.
And then, yeah, exactly.
Oh, no. Yeah, I couldn't remember. And I was like thinking, like, I don't think it has an inversion. I was thinking it doesn't invert just because of the fact that, why was I thinking? It wasn't in any of the SI notes. And like the little sheet that I got from my professor last semester, where it tells you all about the good leaving groups, it doesn't say inversion. It doesn't say anything.
Because if it's an SN1, there will be no inversion, right?
Yeah, okay, so that one is right. This one makes it into a tosslet again. into with no inversion, so it's a wedge. So when it attacks, it becomes a dash.
Yeah.
So that one.
Here.
So I chose these two. So yeah, I feel like that one was right. But
like all of the same things, which makes sense because our scores were relatively close.
Yeah. So, but did you choose both of these for that? Do you remember?
I chose A and B.
Yeah. Okay. Me too. All right.
What she put?
So the next one was which can be made using 1-butene. So, which can be used to make 1-butene. And again, he didn't specify major. So I was like, whatever makes 1-butene. So 1-butene is this, obviously. And then I think your starting material was like an OH again.
Hang on, can I ask you a quick question?
Yeah.
How much does chapter 11 concern you, or does it not concern you? Is it chapter 11? Are we on chapter 11 right now?
I'm on chapter 8.
Oh yeah, sorry.
It's a lot of things, but honestly, a lot of them are like because at the end of chapter 8, I don't know if you see that it has like a reaction coordinate where it has a whole bunch of things. Do you see that? At the end of chapter 8.
Oh, yeah.
Like honestly, I draw that every night. Like every night, I'm like, okay, this one makes
you.
Yeah. Ever since Wednesday, every night I just draw it. And I try to do it from memory a little bit. If I get stuck, I look at the book. But it's just kind of good to just draw like the reagents and know what goes together and know what creates what. And so like I've kind of, to me, it's like I start to see like patterns. Like, okay, this one's going to give me like Markovnikov, and this one too. This one's going to be anti-Markovnikov. This one's going to give me Markovnikov syn addition. This one's going to give me Markovnikov anti-addition. This one's going to give me anti-Markovnikov syn addition. Like, and so it's like it's usually like 4 patterns, and then each one has like 2. It's like 4 reactions, so to speak, or 4 products, and each product has like 2 or 3 reactions that can give you that. So that's how I look at it. It's like, yes, there's 10 reactions, I think that is what it is, but there's only 4 possible products. Like you can only, like 4 things have happened. And so that's how I'm like grouping them, if that makes sense.
Yeah.
Hi guys, I'm in the car, so that's why my video is off. Oh, okay. I just read that. So that's how like I do that. And again, like repetition is the father of learning. So you just gotta keep redoing it, and then at least if you can remember it, you can learn why it's important later. I figured that.
Yes, ma'am.
Oh crap! That just reminded me I didn't print something, because that sheet, that screenshot that Madison sent from SI, I was gonna print it out and like start looking over those. I have to do that tomorrow at work. I'm gonna do that shit. Now that I remember, because I see her name, I'm just like, shit, I should have printed that. Okay, so yeah, so what makes this, the 2, I chose, I think one of the options for this one was more than one, like more than one. And I think this is one I got wrong because he was being a dick and saying you should know it's a major product. But I think the right answer was, it was a tosylate with pyridine. And that was step 1. And step 2 was the butoxide and what would this be? Butanol? Butanol? So that would be like the solvent.
Yeah.
Because that would be like an elimination reaction, right? E2, because that's protic.
Wait, so do you have all of the answer choices written down?
I think the other one I thought it was, because assuming he didn't say major, I was like, well, the other one that can give you 1-butene as a product anyways was the one that was like, it started off with OTS, I think. And, oh, like this one was the one where like he had a starting material, and if you use your starting compound with this, well, you get this.
Yeah.
So the other one was like your starting material is this OTS thing, and then your first reactant was methoxide, and then your second one was, oh no, just methoxide. Hold on, let me write that better.
Oh, so he's asking us how we get the product, right?
Yeah, so he's like, I want you to make this.
Okay.
And so this was one option.
Okay, cool.
If you start off with an alcohol, can you get this? If you start off with OTS, and you add this thing here,
I think yes for the first one, right?
Yeah, this one will definitely give you that because it's the bulky one, so it's going to give preference to the Hoffman, which is the less substituted.
Yeah.
This one is a strong base, strong nucleophile, and this one will give you as the major product that, but it also gives you that as a minor. So that's why I chose the option more than one, because I was like, he didn't say major, he just says what makes this. And I'm like, well, this makes it 2. So that was my reasoning, because I was like, and the only reason, honestly, and I even told that in my email, the only reason I chose this one is because I noticed that in the other questions he would say major. So I'm like, I guess he's only specifying major when he specifies it. Like I was, like I felt like I was fighting with myself to be like, should I take it literally or should I assume shit? Like, should I just assume that he wants to be the major product?
I chose the first one.
Yeah, so you probably got that one right. This one was the one that, yeah. I don't think I got right there. Yeah, so I'm guessing that was the answer. I don't know what the other 2 were. I think the other 2 was like another alcohol, and it had concentrated H2SO4, but didn't have heat. So then again, I thought it was like, did he forget to put heat? Are we supposed to assume there's no heat? I didn't know. So I was like, shit, I don't know.
I just remember, if my memory serves me right, it doesn't a lot of the times, but if it does, I think I remember that was the only option. Like there was only one option that produced the minor product. She said,
yeah, this is the only one that for sure you're going to get Hoffman, the bulk of it. That was the only one. All the other ones, I think there was one other one that could have been, that's also an elimination reaction, which would give you this in a minor product. And again, I was just arguing with him that he didn't put major, so, and I wasn't trying to read between the lines, because I don't really read that between tests. You should be blatant and blunt with what your expectations are.
Madison said she has this one written down.
Who?
Madison.
I have this question written down, the 1B2. Oh, yeah. So, but yeah, I think that was the only answer there. So it was probably the tosylate with the bulky base.
Yeah.
Alright, the next one was, what is the major product? This was that copper one, like that new reaction we learned.
Yeah.
This one I know I got wrong, because this is the one where I read it wrong. So the first step was CH3Br and lithium and copper iodide. The second, and I think somebody did this in the WhatsApp, like they sent the problem and light. And then you had the bulky base and ethanol. Step 3. So step 1 gives you this. Step 2 gives you this.
Wait, slow down. Wait. Oh my gosh. Yes. Agreed.
Step 2 gives you that. Step 3 gives you. Oh no, it's not. See, I did it again. It's not butoxide. It is this.
Wait, I wrote down butoxide though.
It's not. It's not bulk. It's just ethoxide. It's ethoxide.
But wait, why did I write down?
Because he put this CH3, CH2. Okay. So we're so used to associating the K with this because that's usually how it's written. But this, you can, and we forget that you can use other ions.
Wait, did you verify with him that it wasn't terbutoxide?
Yes.
You're kidding me.
Because I sent him I sent it to him, like I sent him this, and I was like, and you have your reactants or whatever,
I feel so dumb.
And he's like, Lean, that is not butoxide. That is ethoxide. It's not a bulky
So
base.
dumb.
But it's because like I think me personally, I thought I saw this. I thought I saw like a subscript. I don't know why. But I think for other people, you probably saw the okay, and you're like, oh, that's that bulky one. Because usually
I never do that. I'm like honestly calling.
He tricks us on this piece of shit, and that's what I'm mad. I'm gonna comment on that too. I'm like, you guys are tricking us. Like, you guys are trying to be fucking sneaky. Like,
I would low key bet $10 that there was a subscript though.
Yeah. So, and honestly, if you were to draw them, like if you would have drawn this and put Na or put K or put lithium, like, and that's why I'm gonna tell him too. Can you not do like the molecular formula? Draw it out. Because if you would have drawn the other one, I would have got that right. I would have been like, okay.
Can you ask him there? Can you ask him again to like double, triple, quadruple check that wasn't terpetoxide?
Yeah, I will. But yeah, he said that wasn't terpetoxide. So anyway, since it's not terpetoxide, the third step would give you double bond right there. Yeah. And that would have been the product. And I think one of the answers. I think that was one of the answers. Yeah. Yeah, I think this was the answer. I did not choose that, obviously. I chose the one that looked like this. So. Yeah, me too. Oh, I'm mad. That sucks. He's being a little sneaky bitch with that. So, the next one is, what's the major product? Oh, this one was the one that he said was an acid-base reaction. I don't know, maybe you can understand what the fuck he's talking about, and I think this is another one I got wrong. So you have this, OH, and then your three steps are PBr3, NaSH, and NaOH. Right? So the first step gives you this. Wait, what problem was it? Was it predict the major product? Yeah, what is the major product of this reaction? Okay. So your first, so the first one we can agree gives you inversion of bromide on the secondary, right? So then this one, this is a strong nucleophile, weak base. I was like, okay, well, this one is going to be an SN2. And this would give you this, right? Agreed. And then he said, oh, God. What does this give you? And I was like, okay. Strong base. Up. I was like, strong base, strong nucleophile. Okay. That's going to give me this, right? And I think this is no. It's an E2 reaction. Because I have it written down from the textbook, and from him as well. Oh, no, yeah, you're right. No, I did not put that in. I didn't choose one of those. I did choose E2. Okay. And I was like, okay, it's E2. Is it wrong? I'm dying. Yeah, so it was like strong base, strong nucleophile, secondary, that's E2. So I was like, this is your product, right? You're kidding. But, and then this one was the one where it's like none of these. Was that the answer? I figured this was the answer, and this was not one of the options. So I chose E, none of these, because E was an option, none of these. But wait, I'm confused. But I think, where is this one at? Wait, did you email him about this one? Yes, I did. Wait, was the E2 product not an option? I can't remember. No, it was not. All the options were SN2 products. So then, yeah, she's so cute. I definitely put none of these. Okay, so, yeah, none of these. And so, and then this one said aqueous, which I don't even know what the fuck that means. Aqueous. I don't know if that matters. I've never seen that before in the book, and he had that on there. But the other products were like either had the OH or the SH, and I don't know what the answer is. But I'm guessing it was either gonna be.
That's effed up. Like I'm gonna throw hands because the E2 mechanism is the right.
Yeah, because it's like, okay, you analyze your substrate. Okay, you have a strong base, strong nucleophile, weak base. Okay, then this sucker comes in who's a strong base. So he's like, I think this is the one he said was supposed to be acid-base reaction. Hold on.
What an asshole move.
Because I have the ones I emailed to him, and this was one of them. And oh yeah, so I put like how I emailed it to him. I was like, I put the product. Like when you use this, you get this. When you use this, you get this. When you use this, you get this. And he said, no, this is an acid-base reaction. So okay, I'm guessing saying this last part is an acid-base reaction. So I'm like, okay, this is a strong base. So then what's the product? Like, what would be the product?
I guess it would probably deprotonate the hydrogen on the sulfur, I guess.
Right? So okay, let's pretend for 5 seconds that you're right. Right? It deprotonates the hydrogen. Then your product would be like this, right? An S? Just an S. Because technically, HS is a strong nucleophile, or like NAS, like negative S. Does that make sense what I'm saying?
I remember like NES was a strong nucleophile, so even if it was like SHR, like it would still be a strong nucleophile.
Yeah, so okay, if this is acid base, okay, it's like it's acid base, okay, fine, that's your product. That wasn't an answer. So none of these would still be right. I got none of these for the wrong reason, but none of these would still be right, right? If this is an acid base reaction, and it has to be from here to here.
I need him to elaborate on that one.
Yeah, so this one is the one I'm pretty sure I got wrong, and I need him to explain.
Can you make sure to ask him about that one?
Yeah, even if I got it wrong, he's like, I mean, he told me what the product was. I still chose the right answer, right? I chose the right answer. Did you choose this? Did you choose none of these?
I chose none of these because I found an E2 product.
Yeah. Okay. Cool. So either way, we should have got the right point for that because
it's true.
We didn't see the product on there. I think it's okay. So the next one is what is the major product, and it's bromine on a wedge, and it's, I think this is acetic acid. And then what is the major product? So I was like, okay, this is secondary. This is weak base, weak nucleophile. I got inversion because it's SN1 and SN1 prefers inversion. And
what? Wait. SN1 doesn't prefer inversion?
Yeah, because it gives you a racemic product. So it's usually 50-50, but the book said that the inversion is always preferred.
But wait, no. SN1, there is no inversion. SN2, there's an inversion.
No, SN1, there's an inversion. That's in the book multiple times. So if this is not the answer, I'm be like, yo, bro, like this.
No, I don't.
The book. Yeah, it's on,
No, remember when you asked it in SI and you said, why is there an inversion for SN2? And I said, it's because there's a backside attack. SN1 does not have a backside attack.
It has but it provides, like, SN1 mechanism gives you a racemic mixture, but it does prefer the inversion as the major product. Because SN1, you still get two products. Remember when it was talking about, whatchamacallit, what page is that? Hold on, let me get it.
I read the book and I don't remember seeing that anywhere.
Yeah, let me get it. That's why I chose that one, because I was like, all right, the book says always choose the inverted product, though, because obviously they don't really give a crap about racemic mixtures.
Okay, I remember the racemic, but I don't remember it saying it prefers the inversion.
And like, this is the thing. If it's wrong, and he's like, well, I didn't say that in lecture. I'm like, motherfucker, I don't care what you said. Because I mean, I don't really, and I'm like, I honestly can't understand half the shit you say. Here it is. It's also in the chapter, but this is like in the chapter review. Can you see? Is it blurry?
It is a little blurry. I can't read it, honestly.
No. Hold on, let me see.
That's better. The nucleophile replaces the leaving group. A racemic mixture, cool. There's like preference for the inversion over retention as a result of the effect of, what the fuck?
Yeah, so, and then if you go to the SN1 part, like the chapter where it talks about SN1, I think it's under, let me see what page that is.
He teach
This
that
is on
in class.
page 61, but where is it? Let me find that.
Did he teach that in class? Like, I don't remember hearing or.
I don't remember either, honestly. And even remember how, this wasn't an answer, but remember that question that had the answer is dextro something?
Yeah.
So I put that in my email. I'm like, hey, and then one of the answers, I don't know if it was the answer or not, but you didn't talk about that in class. And I asked him after a lecture, I'm like, hey, there's a chapter in here talking about D and X where he's like, oh, don't worry about that, but I don't talk about it. In my email, he put, well, I said don't worry about the calculation part. I'm like, I asked you, like, specifically, like, or do we have to worry about this section? I kind of feel like, well, at least he records all his lectures now, so I can be like, pull up the lecture. Because you didn't say that.
I do have a slide with dextro and.
You do? What did I didn't write that down. I honestly didn't.
But I don't remember the inversion thing. And honestly though, if that's if he did grade according to that, remember the problem that we were just talking about? We did it already. I said SN1, there's no inversion.
The HBR.
Was it that one? Remember when it like created a carbocation and then there was an SN1 attack? We did it.
Was it?
But if that's, yeah, so it was, I wish I could tell you which one it was. It was an alkane with an OH attached to it, and then it was treated with HBr.
That was on the previous page.
So it created a carbocation, and then I said, well, the BR is going to attack in an SN1 reaction, so it's going to be on a wedge because there's no inversion. But if there is an inversion, then it would be on a dash. But again, I'm just.
But that one wouldn't. There's like, even though you had chirality with the OH, when the OH left, and you had the methyl shift, the methyl that replaced the carbocation wasn't. It wasn't chiral anymore. Like it wasn't chiral and like it wasn't. No. Stereo. Like what's that? When it's the wedge or a dash, the stereo.
No, the one I'm looking at does though.
Is that the one?
It's an alkane. Honestly, I don't know why I didn't just show you a picture. Let me see.
Which one was it? And we just talked about it. How come I don't remember?
Let me send it to you. Oh my gosh. Honestly, here, let me just show the screen. I don't know anything about technology. Okay. What am I doing? Okay. So the top one, there was an OH on a dash, and then it was treated with HBr. It created a carbocation, and then I said that the BR attacked in an SN1, so therefore there would be no inversion. That's why it stayed on a wedge.
Yeah.
But if Professor Bromick taught based on what the textbook said when he just showed me that the inversion was preferred, then I would be wrong. It would be on a dash.
Yeah, so I'll ask him on that one, but that's why I chose that one as the major product, because of the fact that the book said that someone has a racemic mixture when it's chiral, it has chirality. So, but there's a preference to the chiral. And even in the homework problems, I mean, well, if you did the homework problems, there was examples where the SN1, like it was an SN1 mechanism. It's like, what's the products? And like the wedge, or like depending on what the opposite chirality was, that was the major one. So that's also, again, based on his homework problems. I'm like, you gave us problems like that. So that's why I chose that one. I could be wrong. Maybe that's the one I got wrong. Maybe that's the one like you got wrong. But that's why I chose that, because I was like, it's weak, secondary. There's no heat. That's obviously a weak base, weak nucleophile. It has to be this. So that's what I chose. I don't know what the other options were. The other options were, I think, a variation of that. Like it was either on a wedge. Yes. Oh yeah, the other options were elimination products, or this on a wedge, or none of these. What like, if you didn't have the ants, like this is an option, what do you think would it be? Elimination, or you chose substitution?
I chose, wait, let me see. It's secondary and it's a weak base, weak nucleophile.
So you would have chosen, like, you would say yes, it's SN1, but with the wedge.
I'm just, honestly, I blocked out so much from that exam. Let me go back to my notes. It would be, my lord. Sorry.
Yeah.
Oh, SN1 was, I said SN1 was preferred because that's just what we were taught, right? Without heat, like SN1 will be preferred.
Yeah.
So I probably chose the one on a wedge because I thought there was no inversion. Does that make sense?
Yeah. Okay, so that one is going to be a questionable one for him to answer. We'll see what he says.
Like, interrogate him.
Like, yeah, because it's kind of like, I feel like, and my whole thing is like, SI says one thing, he says one thing, the book is wrong, like, and I'm like, honestly, professor, I can't understand half the shit you say because I don't understand your accent, and if I ask a question, it's like you get mad, like I'm a retard, and I know I am sometimes, but. So this one is like, how many chiral centers, no, how many isomers does this have? So you have to do chiral centers first. So this is one chiral center, right? Because this half is different from this half.
Wait, though. Wait. I remember it being, no, so there's an axis of symmetry, though.
Yes, we will get to that. So.
Oh no, you froze.
No. Get out. So that's how I do it. So I was like, okay, that's chiral. So then I looked over here. It was like, if I split this in half, this half is different from this half, so this is chiral. But so then I like use the formula like 2n, so it's 2 to the 4, right? So supposedly, or 2 to the 2, so equals 4. But it does have an axis of symmetry. So that means that one of the compounds is going to be meso. So I chose 3 isomers. Did you not do that?
Oh, I was on mute. So no. So what I did was, so look at the point on the right.
This one.
Mm-hmm. So the pathway, one of the pathways is a methyl group. There's only one methyl group, right? Yeah. No, on the right. Let's look at the point on the right.
This one. This one?
Is the screen mirrored for me? Let's do that one.
This one?
Yeah, the bottom one. I'll see the bottom one. So we have the methyl group, and then if we're going downwards, we have the CH2.
Yeah.
The CH2, and then that's a CH3 too.
Yeah. So this would be the point of difference, and they're different.
But they're not different. Because look at the top point. Look at the top point. So, like, oh shit. But wait, I'm confused.
This one is connected to 2CH3. So this one, this C is connected to.
Oh, dumbass.
CC.
I got this problem wrong for sure.
Well, hold on, because I might be wrong. So,
no, I got it wrong for sure. I was thinking about it wrong.
Maybe you got it wrong, but I got it wrong too for different reasons. So let's just see if there's like a method to my madness. So the way I looked at it, I was like, okay, like if you go down, like let's pretend he's like, give me the R and S. Does this one have an R and S? So I was like, this is how I go down. Is there a point of difference? It's like there is. This one is different from this one.
Yeah.
So for sure, chiral. So then I did it with this one. That's the same. There's a point of difference. Okay, for sure, chiral. So then I was like, okay, if I were to do like a picture of this, and I did this a wedge, and then this a wedge. Is there the reason I said 3 was because one of these compounds is meso.
Agreed.
And then the other one would be like this would be a dash. Then that one would be an enantiomer. And then if you make this one, that's an enantiomer.
Agreed.
So yeah. So
if I would have answered this again, I would have put what you put 3.
So yeah, so 3. So we can agree that one has 3 ice. And I think it said, oh, what the fuck? This one was the one where like I also got mad because the wording was like super confusing. This one said the wording was identify the stereoisomer.
Yeah.
Identify the number of stereoisomers expected for the following compound. Okay, maybe this was not the one. Sorry, this was not the one that had the weird wording. That wording was pretty straightforward. So that's the one you think you got wrong?
Yeah, I definitely got that wrong. And then I'm so sorry. I don't know if it's Kira. I think it's Kira, but Kira said she got the same thing.
Oh, you chose 3 too?
Yeah.
Oh, okay.
She said she's muted.
So I don't want to unmute, but I also put 3 for this one. Okay. All right. Okay. We concur. All right. So this one was I just put the answer, but it said like if you double the concentration of the nucleophile, like what effect does it have on the reaction? But it was an SN2. I knew it was bimolecular, so I put double the reaction rate. I don't know if you guys remember.
Wait, was it SN2 or SN1?
I thought it was SN2.
I thought it was SN1.
It was. It had like a double bond here, and this was the R, and then it had NH3.
Oh.
So I was like, it was primary. And I think it was primary, and is NH3 a strong base or strong nucleophile? I have NH3 as a weak base, strong nucleophile. Nobody has that?
An H3?
Yeah.
I don't remember writing it down. Let me Google it.
And then I figured it's primary if it's a weak base, strong nucleophile, or strong nucleophile, strong base, it would be SN2. What did you guys put?
Okay.
Kira, do you remember what you put?
I'm low-key mad. So here's why I thought SN1. So he told me in lecture that if it does not have a negative sign, if the nucleophile does not have a negative, you can trust that it will be a weak nucleophile. And NH3, I didn't see anything like on the strength of it. So I thought, okay, it doesn't have a negative. He told me if it does not have a negative, it's SN1. Additionally, I remembered from our quiz, remember when our quiz, it had an SN1 mechanism, even though it was primary because there was resonance?
SN1.
Remember on our quiz when I was like throwing hands because I was like, that's primary. There's no way an SN1 reaction would happen. But the answer was SN1. And the reason why was because there was resonance.
You could be right, dude. I could be wrong.
But I could be wrong too.
So this one will be like one to ask him about, because I'm gonna be like, and this one was like one I thought it was easy. So okay, the guy leaves, right? You leave. Yes, you have resonance, right? So it can go over there. The reason I thought like, obviously it's a weak base, because so we know for sure it's gonna be a weak base because it's charged. I thought it was like a strong nucleophile or even semi-strong, just because a nucleophile, and I think it was in chapter 6, characteristics of a nucleophile is a electron pair or a pi bond. So
Yeah.
NH3 has a pair of electrons. So that's why I was like strong nucleophile.
But water also has a pair of electrons.
But N is more electronegative. So
That's
it
true.
equals electron density better. Or is it more electronegative than water?
But
The reason why I put N, because I have NH3 under my category of weak base, strong nucleophile.
Did you mean to say Na3? I mean
NH3. I have NH3 as like a weak base, strong nucleophile, but I put that in my weak base, strong nucleophile category from the book because I think they mentioned it one time, and I was like, oh, this goes in that. So that's why I was like, okay, that falls in that category. So that's what it is. But I don't know. I could be wrong. It could be if it was SN1, then it would be like no effect. So
yeah, because I would low-key be mad if it was strong nucleophile, because again, he told me if it does not have a negative, I promise I will not try and trick you. It will be a weak nucleophile. So I will be so
nucleophile, weak base, primary, SN2, SN1.
Again, I don't know. It could go either way. But
I also feel like, yeah, it's primary, but I think even in the book, anything that's primary is usually SN2.
No, but remember from our quiz, the answer was SN1.
Oh, wait, hold on. Where do I have that quiz paper?
LOL, I wish I could remember.
Was that one reacting with NH3? It was with water.
It was with a weak nucleophile.
Yeah, I remember it was water because it didn't have heat, did it? No.
No, yeah, I was so confused again why it was.
Yeah, because I remember the one was there. No, but I don't think that one was resonance because I couldn't remember.
We had this like whole full-blown discussion on it. Like I think Brandon was helping me out because I was like, there's no way primary will be SN1. But because there was resonance. So to answer your question, Kira, so if there's resonance, it creates a more stable carbocation. So it's more likely to happen, right? It's more likely to occur. Like we want lower energy. Lower energy is better. So again, if we had a stabilized carbocation, it would lower the energy, making it like more likely to occur. It's more
okay. Yeah, resonant. I think the only reason I chose the bimolecular or thought was SN2 was because of the lone pair on NH3. So I figured like it's more nucleophilic than it's definitely a weak base, but I feel like it's stronger. Its nucleophilicity is stronger, so I put it as a strong nucleophile, NH3. And that's why I chose bimolecular, but we'll ask him on that one.
Oh, wait, so the Zoom is about to stop in less than a minute, and I don't want to upgrade. So can I make a new one?
Oh, but I thought